Okay, now we are going to use slope to determine and identify parallel and perpendicular lines. All right, we're going to talk first about parallel lines. Okay, as you know, or you should know at least, parallel lines are lines that never intersect. Okay, and if you look at the picture here, you got three lines, right? You got your K1, which is your blue line, your K2, which is your red line, your K3. Now, they all look like they're parallel. They all look like they're not going to touch. Now, just keep in mind, this coordinate grid expands. So eventually they may touch, even if they look like they don't touch on the graph. All right, now there's two ways to do this. On a graph, okay, you can use the blocks to count the blocks and use your rise over your run that way. Okay, because rise over run, which is slope, is going to determine whether the lines are parallel or not. Okay, parallel lines are going to have the same slope. Okay, so if I was to take a look at line K1, which is my blue line, and I went from, whoops, there we go, whoop, slide ahead. And I went from this point down to this point, that would be down, okay, I'll use blue, down 1, 2, 3, 4, 5, 6, over 1, 2. So your rise over your run for your blue line is -6 over +2, which is -3. Okay, I go to K2, which is my red line, and I go from this dot down to this dot. That's down 1, 2, 3, 4, 5, down 5, right 2. So your red line has a rise over run of -5 over 2. So right off the bat, guys, those two lines are not parallel because those are obviously different numbers. And then the last line is my green line, K3. So I'm going from this dot down to this dot, which would be down 1, 2, 3, 4, 5, right 1, 2. So for my green line, my rise over my run is -5 over 2. So the green line, which had a slope of -5 over 2, is going to be parallel to the red line, which also had a slope of -5 over 2. So what we're going to say over here to the side is that K2, we'll go K3 is parallel to K2. The symbol for parallel is kind of like a slanted number 11. Now, I'm going to show you this. I'm going to show you this, okay, just so you're prepared for when you get numbers. If you don't have a coordinate grid, you might have to use the slope formula, okay, which is something we talked about earlier. So let's say I was executing the slope formula for line K3, which would be -6, 5 and -4, 0. Okay, so line K3 is going through -6, 5 and -4, 0. All right, so if I label, right, we labeled them x1 and x2, y1 and y2, right? The slope formula is y2 minus y1 on top of x2 minus x1. So that would be 0 minus 5 on the top over -4 minus a -6 on the bottom. Okay, 0 minus 5 is -5. On top of, I would have a super plus down here, -4 plus 6, which is 2. So you're getting the exact same slope as you did when you did it graphically. All right, we practiced that, earlier, so I'm not going to go crazy with that. If I went to my red line, we would take that point and we would take that point. We'd execute the slope formula. And if you do it correctly, you should get -5 over 2, because obviously that's what we got on the graph. And then same thing with your blue line. Your blue line, you have 0, 6, and you have 2, 0. So if you executed the slope formula there, you would get -3. All right, the only ones that are parallel are the ones that are the same, which we determined was K3 and K2.